In this video, we will use Laplace transforms to solve for y of t. It's a first-order differential equation, but Laplace transforms still work for first order. The Laplace transform of y prime is s y of s minus y of 0. Then the Laplace transform of 2 times y of t is going to be plus 2 y of s equals the Laplace transform of t to the fourth, according to the table, is 4 factorial over s to the 4 plus 1, which is equal to 24 over s to the fifth. Okay, so the object is now to solve for s, or y of s, so s plus 2 times y of s minus y of 0, which is given to be equal to 2, equals 24 over s to the fifth. So s plus 2 times y of s is equal to 2 plus 24 over s to the fifth, or 2 times s to the fifth plus 24 over s to the fifth, so that y of s is equal to 2s to the fifth plus 24 over s to the fifth times s plus 2. Okay, now to find the inverse transformation, where we'll apply partial fractions and see what happens. The partial fraction expansion is going to be a over s plus b over s squared plus c over s cubed plus d over s to the fourth plus e over s to the fifth plus f over s plus 2. The bottom is a polynomial of degree 6, and so not surprisingly I have 6 constants that have to be found. Okay, so let's clear out the denominator. We get 2s to the fifth plus 24 equals a s to the fourth times s plus 2 plus b s cubed times s plus 2 plus c s squared times s plus 2 plus d times s plus 2 plus e times s plus 2 plus f times s to the fifth. Okay, now our usual technique of plugging in numbers will give us some help. If we plug in s is equal to 0, on the left-hand side we get 24. If we plug in s equals 0, on the right-hand side, the one term that survives is going to be this one. So we get 2 times e. And so therefore we conclude that e is equal to 12. The other number that we can plug in that makes sense is negative 2. On the left-hand side we get negative 32 times 2 makes negative 64 plus 24 equals, if I plug in negative 2 on this side, I'll get all of these go away, and all that's left will be here is negative 32 times f. And so that gives us that f is equal to negative 40 over negative 32, or plus 5/4. Now, for all the other terms, we could plug in numbers, but this is actually the rare example that multiplying out is actually the preferable way to go here. So 2 times s to the fifth plus 24 equals, let's multiply out and see what happens. We get a s to the fifth plus 2a s to the fourth. Multiply these, we get plus 2b s to the fourth plus 2b s to the third. Multiply these, we get plus c. I shouldn't have had a 2 here, I apologize. cs the third plus 2cs squared. Then I have ds squared plus 2ds. Then over here I have plus e times s plus 2e. And then lastly, plus fs squared. So that's going to go back here in the fs to the fifth. So what I've tried to do here is put the s to the fifths, fourths, thirds, squareds, constants, and linear terms together. Okay, now let's match up the pieces. So the s to the fifth terms, we have that 2 is equal to a plus f. A we found earlier to be 5/4. Sorry, f we found earlier to be 5/4. And so therefore a is equal to 3/4. Okay, let's just continue down. So here I have 2a plus b equals 0. There's no s to the fourth on this side. So that means that b is equal to negative 2a. So b is going to be equal to negative 3/2 because I already know what a is. Continuing this way, 2b plus c has to be equal to 0. So that means c will be equal to negative 2 times b, which will be plus 3. Then in this column, we have that 2c plus d equals 0 because there's no s squareds over here. And so that means d is equal to negative 2 times c, so d is equal to negative 6. Now we could continue to solve for e, but we've already done that. We found that e was equal to 24, and we also found that that e is equal to 12, and so we've got all the letters. We have found e and f already. Okay, so we're just about done with the problem now. We have found that the partial fraction expansion is, so y of s is equal to 3/4 over s minus 3/2 over s squared. Then I have plus 3 over s to the third minus 6 over s to the fourth. Then we had plus 12 over s to the fifth. And then finally plus 5/4 over s plus 2. Now to find the inverse transformation, I'll first do this. 3/4 times 1 over s, that's fine. Minus 3/2 times 1 over s squared, that's also fine. The next term with s to the third, I'm supposed to have 2 factorial on top. And so I need to have a 3/2 in front to compensate. The next term involving s to the fourth, I need to have a 3 factorial on top, which by nice coincidence I've got already, so that's times 1. This term with s to the fifth, I need to have a 4 factorial on top, and so I need a 1/2 to compensate, so I get a 12. Then the last term, 5/4 over s plus 2. So applying the inverse transformation, we get that this is equal to 3/4 constant minus 3/2 times t plus 3/2 times t squared. The next one's minus 1 times t to the third. The next one is 1/2 times t to the fourth. And then on this bit, I get plus 5/4 e to the minus 2t. And so that is the solution of this differential equation using Laplace transforms.